Hey Math 098, we left off on this problem, and what I need to mention for you is, as a reminder, is you can also use a graphing calculator as well as this method of the common base, and I just left off with this answer if you have a good idea of where the answer is, okay, because you might need to zoom in to see that that's actually a point of intersection to get x equals -4. Now, what do you do if you get a problem like 7 to the x equals 21 where there's no common base? In other words, 7 is a prime number, and you can't change that value. And it's impossible to change 21 to be 7 to some power. I don't know. 7 to some power gives me 21, apparently. But it's not a whole number. It's going to be a decimal. So what do you do, I guess? And again, if you're confused, like you can break down 21 as 3 times 7, but that's multiplication. That's not a power. So this is where I would go to a calculator, go to y equals, and change the problem to be 7 to the x power. And then a second equation is just y equals 21. Now here's the thing, is when I go to the graph, I'm not going to see the horizontal line y equals 21. I'll even show you. What I have to do is change my window so that the y max goes up to, I'll make it go up to 30, so that you can see, y equals 21, the horizontal line. So now if I hit second trace, I'm going to calculate, that's why I hit second to calculate, C-A-L-C, the point of intersection, the fifth option down. I just need to move my cursor to the right until it hits pretty close to the point of intersection. Hit enter once for the blue curve, once for the red curve, and then a third time for my guess. And I'm going to round this to 3 decimal places. I think you guys know me by now that I like 3 decimal places, so about 1.565. In this method, I want you to use a calculator, and you can use Desmos as well, or your own calculator, when you cannot get the same base. So that's what happens in this problem. There's no way to get 7 to a power to give you 21. The other 3, the 3 I went through in the first video, worked. That fourth one did not. So then we're going to move on to the compound interest formula. To me, it makes the most sense to go through this formula after you know what it is. So it's compound interest, and the P in the problem stands for the principal. So that's how much you start. I don't know how well versed you guys are with this. It's the starting amount. R is the rate. Now make sure you change the rate as a decimal. So as we look at this problem, yes, the rate is 9%, but you better type in 0.09. I can go into more detail with that. T is time. I'm not trying to trick you guys in this one, but with compound interest, time is in years. So in one of my pre-calc classes one year, I think I used 6 months one time, and a lot of students put 6 in for T. Well, 6 months is half a year, so they were supposed to put 1.5 in. And then N, that's the most complicated part here, is the number of compoundings. So that changes depending on what the key words are. So in this case, it's compounded monthly. Well, in this case, N must be 12. You might see daily. Well, there's 365 days in a year. I know there's a leap year, but let's just stick with 365. Weekly, there's 52 weeks in a year. Quarterly would be 4. Semi-annually would be 2. There are lots of different values there. One more thing I didn't mention is the A value. A is the ending amount. So those are all of the variables. So let's go ahead and get to the problem. So they're asking you for the ending amount at the end of 5 years. If we start with 1600, so I'm replacing P with 1600. 1 plus, I already talked about changing the percent to a decimal. By the way, the word percent literally means out of 100. Per means out of. Cent means 100. There's 100 cents in $1. So 9 divided by 100, that might help some of you understand why it's 0.09. I already mentioned that monthly means there's 12 months in a year to the 12 times 5 power. So t is equal to 5 in the problem. So from here, you just go to a calculator. I'll put a box around this. But the final answer, I want you to round to the nearest penny because we're talking about money. So just using a calculator. So quit out of this. Let's clear this out so that's not bothering you. 1 plus, again, I can type in the fraction, 0.09. Some of you might have to hit the divided by key. And then some of you, when you do your exponent, you might need to put in parentheses. I do not. I don't have to use parentheses. I forgot what the exponent was. 5 years, so 12 times 5. Because you have to multiply before you take that power. Some of you might actually figure out 12 times 5 is 60 and take it to the 60th power. And make sure your answer makes sense. I've done compound interest problems before where students tell me that the end 5 years they'll have $1 million. You know, if we start with 1,600, 2,500 sounds pretty good. That sounds legit after 5 years. 9% interest is really good, by the way. So $2,505.09. 2505, and nearest penny means 2 decimal places. So that's the answer I'm looking for. So some more word problems. Now, some of these word problems really aren't that difficult, just so you know. They may have a lot of words, but at the end of the day, here's your formula, and you just have to use that formula. So as you hit pause in the video and read through the problem, this is the same problem out of the textbook, by the way. You know, it's asking you to estimate the percent of light that will pass through the following number of sheets of glass. Oh, I don't have the number that I want here. I think it was a table, wasn't it? Yep, I definitely messed this up. In part A, they wanted 2 sheets of glass. And in part B, they wanted 10 sheets of glass. And if you're curious, I'm on page 6045. So I'm letting you know where I got this problem from. So what you could do is you could just plug in 2 in for n or 10 in for n. But because they want you to do this twice, I do want to show you a trick with a calculator. Is if you go to your y equals, let me clear this stuff out, and you type in that same equation, 100, and you can make it look exactly like the problem in the book. You just might need to put parentheses around your exponent. Whoops, negative 0.05. And I'm going to use x instead of n. And you can double check that that's the same equation. And it is. And what you could do instead of going to the graph is you can hit second graph. And you can look at your table and say, okay, well, at 2, we're going to get 90.545. 90.545% will pass through. And then at 10 sheets, so instead of having to go back through and plugging in all of the numbers again, I can just go to the table and see that at 60.858. And you can even see here, I ask you for the nearest thousandth. Now, feel free to try this problem doing other methods. You know, you don't have to use my graphing calculator. You can use Desmos. You can, you know, figure out your own calculator. Just make sure you get answers that match here. Yeah, we're ready for the assignment now. Notice that I did assign all of these last ones. I know a lot of times I just assign odds, but make sure you do all of them.